Hello friends, welcome to Secret of Electronics. In this video, we will learn how to make a digital dice using the Attiny85 microcontroller, a shift register, and a 7-segment display. The circuit diagram shown is for a digital dice project based on the Attiny85 microcontroller, a 74SC595 shift register, and a common anode 7-segment display. The Attiny85 serves as the brain of the circuit and is powered by a 5-volt supply. A push button connected to pin PV3 of the 8985 microcontroller is used to trigger the dice roll and is pulled down using a 10 kilo ohm resistor to prevent floating input. The microcontroller communicates with the 74SC595 shift register via 3 lines. Data SER on pin 14 of the 74SC595 connected to PV0, clock SRCLK on pin 11 connected to PV1, and latch RCLK on pin 12 connected to PV2. The shift register expands the number of output pins, enabling it to control the 7-segment display. Each of the Q0 to Q6 outputs, pins 15, 1, 2, 3, 4, 5, and 6 of the shift register, drives one segment of the display through 220 ohm current limiting resistors R1 to R7. The 7-segment display is common anode, meaning all anodes are connected together and connected to 5 volt, while the cathodes of the segments are driven low by the shift register to turn them on. This setup is ideal for compact digital dice applications where only a few microcontroller pins are available. The given Arduino code is written for a 8985 microcontroller to implement a digital dice using a 74SC595 shift register and a common anode 7-segment display. The code defines pin assignments where PV0, PV1 and PV2 digital pins 0, 1 and 2 are used for data, clock and latch signals respectively. To control the shift register, the PV3 digital pin 3 is connected to a push button used to trigger the dice roll. A array named dice numbers holds the inverted binary segment patterns for numbers 1 through 6 as required for a common anode display, where a segment is turned on by sending a low signal. In the setup function, the relevant pins are configured as either inputs or outputs, and random seed analog read 0 is called to ensure that the dice roll result is random on each power up. By seating the random number generator with analog noise from a unconnected pin, the loop continuously checks the state of the button. When the button is pressed, digital read button underscore pin equal high. It generates a random number between 1 and 6, representing a dice roll. It then calls the display number function to display the corresponding digit on the 7-segment display. Inside display number function, the latch pin is pulled low before shifting out the segment data to the 74SC595 shift register, and then pulled high to latch and display the number. A 500 millisecond delay is added to debounce the button and visually stabilize the display output. This code provides a simple, efficient way to simulate a physical dice roll electronically. Now we will use a Arduino Nano as a ISP programmer to program the Attiny85 microcontroller. If you do not know how to program the Attiny85 using the Arduino Nano board, then you can watch our detailed tutorial by clicking the I button. Next, connect the ISP pins of the Attiny85 microcontroller to the ISP pins of the Arduino Nano board according to the circuit diagram shown on the display. Now connect the Arduino Nano board to the PC using a USB cable. After connecting, open the Arduino IDE and open the code file, which you can download from the link provided in the description. Once the code file is open, select the correct settings under the Tools menu. After selecting the correct settings, click the Upload button in the Arduino IDE. The code will then be uploaded to the Attiny85 microcontroller. Now connect all the components together according to the main circuit diagram we discussed at the beginning of this tutorial. As you can see, when I press the push button, a random number is displayed on the 7 segment display. If you liked this video, do not forget to subscribe to our YouTube channel to watch more interesting tutorials coming up.